We will now be talking about Land Tender and how Land Tender, the decision support tool, was used by the Truckee Fire Protection District along with this CWPP process. So, who am I? I am Joe Flannery. I'm the Director of Partnership Success here at Vibrant Planet, which means I help out collaboratives and working groups and agencies all over this state and in other western states using Land Tender for landscape resilience and community protection projects. I actually live just down the hill from everyone. I live in western Nevada County in Nevada City. For those of you who know me, I'm sorry I missed you in person today, but I lived in Truckee while working for the U.S. Forest Service for over 10 years, and really sad that I couldn't make the journey over due to the inclement weather. We're going to start by kind of laying out the basic steps of community protection and landscape resilience. This will give us a sense of how Land Tender was used to complete those same steps in maybe a more efficient way. What are those basic steps that agencies and collaboratives and working groups go through when engaged in community protection and landscape resilience? Well, first, we want to determine all the landscape and community features that have societal value. And I'm looking at this picture and I see a lot of them, right? I see homes, I see streets, I see beautiful trees and beautiful landscapes that surround our community. Just over those buildings, there's a beautiful river, the Truckee River, providing fresh drinking water and recreational opportunities downstream and to the existing community. A lot of landscape features that have societal value in the Truckee Fire Protection District. Next, we want to determine the hazard that can negatively impact those values. And today we're mostly going to be talking about wildfire hazard. So we have values and we have hazard. When you put them together, that is risk. After we determine our hazard and really get a sense of our risk, we then want to determine the methods to mitigate that risk. And usually we want to do so with the least impact to values. Now this creates a trade-off. Now all those trees in that picture there, we could go cut down every single one of those trees and remove all the trees in town, and we would significantly reduce our wildfire risk. But who wants to live in a town surrounded by a barren wasteland? That is an exaggerated example of a trade-off. We always want to try and mitigate our risk with the least impact to those same societal values that we're trying to protect in the first place. And the last step is we then determine the most appropriate locations to reduce that risk with limited resources. As we all know, there's limited resources from funding standpoint for project implementation and from just time to implement risk-based projects. Once we determine the risk that should be mitigated and the way we can mitigate that risk with the least impact possible, we then need to prioritize and sequence where this can occur. And how is this generally accomplished? Well, these days, a lot of collaboratives in our area, around the state, and all around the West have gotten pretty good at this process. And we kind of rely on three circles, and that is starting with local expertise, and there's some great local expertise in this community. I know that firsthand from living there for so many years. And these days, we really do rely on a lot of science-based frameworks. We also can use data. There's a lot of really good, high-quality data out there that can actually help us get a glance at our landscapes and our hazard, etc. And you put those all together, and we call that systematic planning. When there's a systematic plan in place, it creates transparency, it creates trust. It allows us to go through these steps in an organized fashion and get buy-off from our stakeholders and all the concerned community members. So why bring Land Tender into this equation? Land Tender is a decision support tool, as I mentioned before. And really what Land Tender does is it utilizes technology to decrease the timeline of that systematic planning, to increase transparency and collaboration along that process. It can really help us assess and weigh trade-offs more efficiently. And last, it can help us prioritize and sequence those risk mitigation treatments at scale, meaning we can take a glance at the entirety of the Truckee Fire Protection District or the surrounding landscapes at one time using Land Tender. So let's look back at our concentric circles, and now we're going to add technology into the mix And technology, like we just mentioned, is going to really increase our efficiencies. It's going to let us plan at scale and plan at scale very quickly. And we do think it lends itself to a more transparent and collaborative process. Okay, so let's actually go through those 4 steps again. You can hear those steps a couple times in this presentation and see how we actually engage in those steps while utilizing land tender in the Truckee Fire Protection District, starting with step 1, determining all the landscape and community features that have societal value. We're actually looking at a screenshot from land tender. These are all of those features. I see some green in there. That's the WUI area that surrounds our communities. That was already determined as part of this process. I see some purple in there. That's our large recreation sites, our ski areas. I see a lot of orange lines, our transportation network, and our critical evacuation routes. And we have another mixture of our resources, right? I can see some aspen stands. I happen to know the colors. I see spotted owl packs and these obligations we have to sensitive species in the area when we go about planning our mitigation treatments. And the best part about land tender and working with this group is all of these landscape features that have societal value, and we're going to learn their name in a second. These were all locally sourced. So we worked hand in hand with the Truckee Fire Protection District and SWCA and the stakeholders to actually get this data and bring it into land tender. Like I said, we have a name for these landscape features that have societal value. We call them strategic areas, resources, and assets. Let's add another acronym to the mix. We call them SARAs. So what defines a SARA? So a SARA has to have societal value. I think all the landscape features that I just mentioned a moment ago, our waterways, our evacuation routes, our structures where we all live and work, our recreation sites, all have societal value. Those SARs also have to be able to be affected by disturbance. That's the whole point, right? We're trying to mitigate the risk of the hazard to those SARAs that have societal value. And of course, they have to be able to be mappable. We have to know they exist in the real world, and then we can express that acute existence within land tender. And we just saw that map just now. To bring in a little more detail to it, and really define the acronym SARA here, we have things like WUI areas that I mentioned that we saw in green. WUI, and that's the SA in SARA. It's a strategic area. We have resources like an aspen stand, classic example in the Truckee area. And of course, we have assets like our primary residential structures. We also organize the SARAs into categories. And I'm going to circle back to this in a little bit. It actually promotes an ease of planning and planning at scale within the landscape. And so you notice many assets are like homes and businesses and our utility infrastructure are grouped together in an asset category. Moving down, we have recreation category, which includes our local trails, our recreation buildings, some of our parking areas, our ski areas that I mentioned before. So this will come into play a little bit later in the presentation, the organization of the SARAs. SARAs actually also have predetermined response functions. So each SARA has a predetermined response function to hazard and to treatment. Now let's actually take a look at that with an aspen stand, and I'll explain a little bit more about response functions and the nuances to them. All right, got a beautiful aspen stand. This is just an example of one of the many resources around the Truckee Fire Protection District. Maybe this is an aspen stand over there on Alder Creek Drive, or maybe it's further out towards Sage Hen. These beautiful places that we like to hike. Now, an aspen stand may have a certain response function to high intensity fire. It doesn't like it. That resource is going to react negatively to that hazard, that high intensity hazard. But it may have a different response function to low intensity fire. Aspen stands actually like low intensity fire. It can take away the encroaching conifers. It allows sunlight to reach the floor of the aspen stand. It'll regenerate itself. So the point here is that the acute response functions to fire can vary. Not all fire is bad, and it can vary amongst different flame lengths. The same thing goes for treatments. When we thin an aspen stand, here's a photo of a thinned aspen stand, we're kind of playing nature's role of fire, right? When we thin the aspen stand using mechanical equipment, it actually likes it. Just like a fire, it clears out the conifers that are encroaching, sunlight hits the floor, and you can see here in the picture the aspen stand is regenerating, and we're going to increase biodiversity in these areas. Other treatments might not have the same effect. Look at herbivory for an example. Grazing is a great way for us to reduce fire hazard in aspen stands and around the community. Now, acutely within an aspen stand itself, it might not be the preferred method of wildfire risk reduction. When aspen stands are overgrazed, they can actually send a signal down to the roots to stop producing shoots. Why keep producing shoots when they keep being eaten? And we can actually lose aspen stands. So just like different types of fire can have different responses from aspen, so can different types of treatments. All right, moving on to step 2. So now we know we have these SARAs, and each individual SARA is going to respond differently to different types of fire intensities and different types of treatments. The next step, of course, is to determine all the hazards out there, the locations of high intensity fire that can negatively impact those values, the SARAs. Here we're looking at our fire hazard map. As we can kind of tell by looking at it, the areas of brighter pink, some people call that red, it looks pink to me, are the areas that have higher hazard. I also want to mention that this is a wildfire hazard map. As we look at some of the urban core areas, I can see Tahoe Donner on the map. Right there in the heart of kind of Tahoe Donner, or the heart of downtown Truckee, wildfire then becomes an urban fire in those areas. And our model is a wildfire hazard model. We're not saying there's not a fire hazard within those communities and those core urban areas. We're seeing at that point the fire has transitioned from a wildland fire to a more urban fire. So we use a wildfire hazard model in land tender. And of course, the next step is we then expose all of those SARAs, all of those landscape features that have societal value, to that landscape hazard. Value and hazard is basically risk. A little bit more about our wildfire hazard model is a stochastic fire model that's has 2 parts to it. It has the likelihood, we call it actually burn probability, and then if a fire does occur based on that probability, what is the intensity of that fire? And then intensity, as we learned from the aspen stands, can vary across the landscape. Sometimes it can be very intense. In other locations, the intensity could be much less. This is a lot of information about our fire hazard model. On the burn probability side, we use FSIM, which is a model run by Pyrologics, our sister organization. They've also created an in-house fire intensity model that's called WILDIS. And when you combine those two together, the Truckee Fire Protection District is really getting the industry standard fire hazard model for both burn probability and fire intensity. Again, burn probability is the probability that a fire will occur on the landscape. And how is that determined? That's really determined based on thousands and thousands of iterations, essentially lighting thousands and thousands of fires as they move across the landscape, using stuff like relevant fuel, weather, topography, and historical fire occurrence. So an area that maybe fires could start more regularly, maybe outside of the I-80 corridor, is that taken into account? It sure is. I do want to mention too that all the burn probabilities are based on fuelscapes, kind of a snapshot of the burnable fuels in the area. And this was actually based on the industry standard land fire fuelscape that was actually additionally calibrated specifically for the Truckee area. Moving to the right side, the intensity, we then take those probabilities and we say, if an area is going to burn, what is the intensity of that burn going to be? And for WILDIS, we actually use over 216 different weather types, various combinations of wind speed, fuel direction, wind direction, and fuel moisture content, etc. So again, does WILDIS in combination with burn probability FSIM, does it take into account a prevailing wind on an August day? It sure does. Does it also take into account maybe a freak east wind on a September day? It does. We're generating burn probabilities and fire intensities over an entire year. Unlike some other fire hazard models that pick one day, we're burning an annualized burn probability and then generating our intensity from those probabilities. All right, let's move on. So now we have our SARAs. We know where they all are. We then have a hazard, and we know that hazard varies in intensity across the landscape. Behind the scenes, land tender also has predetermined the operability, basically the possibility of a slew of different types of treatments that could actually mitigate that risk. Treatments that could occur on the landscape. We're looking here at mechanical treatment, where it could occur in the Truckee Fire Protection District. Another example, mechanical rearrangement. How could we come out and masticate the fuels? And if you notice, a lot of these are overlapping. So there's different options for treatments in some of the same locations. And going back to our aspen example, land tender's always going to try and pick the treatment that can mitigate the risk the best, while also not negatively impacting the SARA in question. So how do we unlock this? In land tender, we allow users to emphasize first and foremost the category of assets and the category of SARAs that they would like to protect first and foremost. On the left-hand screen, you see those categories of SARAs and the different weights that we can give to those SARAs. If you remember, I mentioned that all SARAs are lumped into these categories. In this hypothetical example, we have a typical user in land tender assessing how trade-offs, basically, how resources should be allocated based on SARA categories. Here we see a lot of emphasis put on the protection of assets. We see the maximum amount put on the emphasis of safety assets like evacuation routes, WUI areas, etc. We see some emphasis put on recreation and biodiversity, and then again at water. Land tender quickly thinks of all those areas where those SARAs can exist. It then takes the actual weighting objectives and it weights the response. It then spins through all the potential mitigation treatments and assesses those against all the different types of fire intensities, and we end up with this kind of heat map, if you will, of the Truckee Fire Protection District. This is an acute example based on the sliders and the weight objectives on the left-hand side. There's like 64,000 combinations by which a user could weight their objectives and come up with a different heat map in the Truckee Fire Protection District. The areas that you're seeing that are dark blue that kind of jump out to us, those are the areas that we say have the highest restorative return on investment. Another acronym called RROI. Those are the areas where we can have the greatest impact to reduce the risk to the SARAs that we care about as weighted as we see on the left-hand side. So of course, we want to actually go out and treat the landscape where we're going to have the most impact. Which also brings up the fourth step. When I look at this blue heat map, that's a lot of work to be done. This could take 20, 30 years and cost millions and millions and millions of dollars. We might not have those resources at our disposal, and we might not have that time on our side. Which brings up the fourth step, and that's how do we determine the most appropriate locations to reduce the risk with the limited resources we have. Another one of those trade-offs. We know we can't treat everywhere the first year. How does one go about doing this? We take that blue map that we saw a moment ago, and we can then further constrain that blue map based on constraints, such as the amount of acres we could realistically treat in 1 year or in one project, the number of projects we want to actually see in the landscape, or the amount of funding available to us, or a combination of all three. This is another hypothetical example. You're not going to see this map actually reflected in the CWPP. I built this just for the sake of the presentation. This is expressing a typical user with the objectives that we saw weighed a moment ago. And we see the top 10 projects at 5,000 acres that could take place in the Truckee Fire Protection District. And remember, this map and this variation of projects is acute to a single user building a single project and weighing their objectives accordingly. There's additional steps that will be required. Just as one user would weigh their objectives, like we saw, maybe emphasizing assets, a lot of safety, a little bit of biodiversity, a little bit of recreation, and so on, other users could actually weigh their objectives differently still. And that's exactly what occurred here on the Truckee Fire Protection District. We had many stakeholders, along with the district itself and other agencies, create individual scenarios weighing objectives. We could then actually blend all those scenarios together by using our comparison builder. And here we see we're clicking on 3 of them. We're going to kind of mash them all together and see where the areas of consensus overlap. And that brings us to a map like this we could also see in land tender. What I'm looking at here are areas of majority consensus and complete consensus. This is a project that basically takes individual users and their individual influence of what they think should be protected in the Truckee Fire Protection District and finds the area of commonality. So we've now moved through all 4 steps. We assess the landscape for all the societal value and all those features that are important to us to protect. We then exposed all of those things that we want to protect to a wildfire hazard. We then actually weighed our objectives and said, we want to protect some of them more than others at times. Landtender quickly spinned through all of the fire hazards and the available treatments and the emphasis put on, along with constraints, to generate one single project. And then we merged several projects together to end up at a map like this. And I'm speaking again in hypotheticals. But I want to thank you for your time. And now I'm going to turn it over to Dylan Sheedy. And you're going to hear not hypotheticals, but how this was actually used in the Truckee CWPP process. Thanks for your time.